Good afternoon, everyone. It is once again Ted the Speed Learner, and I am well aware that I have not done a video like this in, well, at least a year, if not more. And there are many reasons for this. So one of the biggest ones is there were some things that happened in my house that made things kind of complicated. Not to mention the fact I did take those trips. You remember all those parades I videotaped? Well, I also took trips to videotape other things besides just the parades. And so when you sit there going, well, gee, you videotaped the parade. Wait a minute, you did all that sign work on the same day you did the parades? Yes. This year has been an extremely hot year, and right now it is November 30th, and yesterday our area got 8.5 inches of snow, which forced our store to close. And it's been our store closed again today. Long explanation, won't go into it today. But anyway, one of the questions you're probably going to ask me is this. Why are you doing Euclid's Elements all over again? Well, the reason I'm doing it all over again is because I did it in low resolution 16 years ago. And when you're doing something like that in low resolution, yeah, my internet wasn't as good back then as it is today, and I have a more well-established channel than I did way back then. So we're going to do this. I am on the floor, and there are good reasons for that, and we'll get into that later. But when you're doing Euclid's Elements, and we're going to start with Euclid Book 1 definitions, you're going to have two tools and only two, okay? The first tool is a compass. This is an actual compass. As you can see here, not one of those mock compasses that they give the little kids back in grade school. This is the real deal here. Okay, this is a real fancy compass. And the second thing they give you is a straight edge. And as you can see here, this is a ruler. You could use a ruler as a straight edge. The idea is that a real straight edge would have no measurements whatsoever. Do you really think that Euclid had any measurements? No, he didn't. Now, the next question I'm going to get is, why am I drawing this out for you? Because unlike other videos that you will see on YouTube or Rumble or Facebook or whatever platform you prefer, they'll draw this on the computer. Ooh! I'm going to show you can actually draw this out in person. You can actually use your hands to draw this stuff out. Okay? So, we are going to cheat a little bit. You're supposed to use a pencil, but I don't really own pencils anymore. That's kind of a thing of the past. I do own an ink pen, however. I'm going to use the ink pen. Okay? And we're going to go through. These are Euclid's definitions. Euclid had several books. He had 13 in all. And he had definitions in several of these books. So we're going to go through each and every one of them, and then I will show you how to draw everything, okay? Now, first things first. Euclid is going to say, a point is that which has no part. Okay? Now, what he means by that is, when you plot a point, and if you've been regularly watching my YouTube channel, you know that I've done some videos on René Descartes. Let me tell you a couple things about René Descartes. Number one, he did not just say, dump Euclid and pay only attention to me. He never said that. Number two, it cannot be conclusively proved that he ever created the Cartesian coordinate system. Now, having said that, I can say that he laid the ground foundation of the Cartesian coordinate system. That he did do. But to say that he created the Cartesian coordinate system, no. However, if you have ever graphed x and y axes, okay, then you are familiar with points, especially when those points have coordinates. Okay, that's why they call it the Cartesian coordinate system, because Cartesian is the Latin name for René Descartes. I don't know whether you knew that or not, but it is. But anyway, so what they do is they have you make this horizontal axis, this vertical axis. That's why we have graph paper today. And they also show you how to draw things like slope. Okay. Now I wanted to go through some of this before I get into this too much. But anyway, when you're talking about René Descartes and the Cartesian coordinate system, you hear the word horizontal axis. Well, when you look at a sunrise or a sunset, what do you see? The horizon. That's the line that divides the ground from the sky. Get it? Okay. So horizon, horizontal. What about vertical? Okay, that's important too. Now, if you've ever had anybody that suffered from vertigo, you know what vertical is. Okay? Watch a space shuttle go up in the air. That's a vertical climb. It's not a straight vertical climb, but it is a vertical climb nonetheless. Okay? Matter of fact, they have some of these soda pop things where you could put Mentos in the soda pop, and if you do it just the right way, you can launch the soda pop bottle in the air, like 10, 20 feet. Even fireworks, you could do that. Have you ever seen a fireworks show where they shoot the fireworks up in the air? That's vertical right there. Vertigo, vertigo. Okay. Enough of that. So, let's do this definition again, because I've given you a lot of information and you need to memorize it using the mnemonic devices that I taught you guys back in the peg and link system in mnemonics. Okay, you're going to memorize all this stuff. Well, once again, the definition says a point is that which has no part. Okay, nothing is smaller than a point. Nothing. Okay? Now, let's go through the next one. Definition number 2. A line is a breadthless length. Okay? Now, let's go ahead and draw the line. We're just going to draw a simple line like this. And maybe we'll have to draw that line again. There you go. There's your line. And I hope you can see this. Let me zoom in just a bit. Let's move this out just a pinch. There you go. I know it's a little loopy, but you kind of get the idea. This is a line. Now, why'd they call it a breadthless width? Okay? Now, you'll often hear the terms length and width, but you will not necessarily hear the terms length and breadth. Okay? Breadth literally means width. It's another term for width. Okay? So now we're drawing a line. And it says the extremities of lines are points. Okay, let's put a point right here and right there. What they're actually saying, what Euclid was actually saying here, is that if you get to the end of a line, you're going to find a point. Okay? And it's just like when you get to the end of the road, you might find a sign. Get the picture? Same concept. Okay. So, this is one end of a line, this is the other end of the line, and they're represented by points. Okay. Definition number 4. A straight line is a line which lies evenly with the points on itself. Okay? So, let's say we put a point here, 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 and here. Okay. A straight line will lie evenly with all these points. Okay? That's all he says. Now, we got to draw a surface. Well, give me just a second here. Just gonna, I don't know if you can see this or not. I'm gonna try to do this best I can. Let's go way down. I know that that's an awful looking surface, but it'll serve our purposes. We just basically drew a square. This is a surface, okay? Now, if you have a book, well here, I got it. Oh, hang on just a second. Box of trash bags. There we go. That's a surface. And if you move this over right here, that's a surface. That's a surface, and that's a surface. And this one right over here is a surface. Okay? One surface, one surface, one surface. It has length. You can see that. It has width. You can see that. But it has no depth. Okay? A surface doesn't have a depth. But we will get to things that have depth in just a minute. But now you got that one. Okay. Let's go on with the definition, shall we? The extremities of a surface are lines. That's a surface. And the extremity of this surface is a line. There's one line, two lines, three lines, four lines. These are the extremities of the surface. Getting that so far? Let me do that one more time because you couldn't see that. One line, two lines, three lines, four lines. All four of these lines are extremities of this surface. Okay, let's go on, shall we? A plane surface is a surface which lies evenly with the straight lines on itself. Okay, as you can see, there's no bubble on top of this. Okay, that's just what they call a plane surface. There's nothing above it or below it. It's just that. Okay? Okay. A plane angle. What is a plane angle? It is the inclination to one another of two lines. Okay, we're going to have two lines. Let me make them. Okay. Line number one. Oh boy, I'm having trouble with the lines today, I tell you. Okay. And then, line number two. And we're not going to measure these. There's no need. Oh, I'll be danged. We're still having problems. Okay. Let me show you. Okay, you saw me draw them. Great. Let's go through the definition. A plane angle is the inclination to one another of two lines. We got two lines that are inclined to one another. And if you want to look up the etymology of the word inclination, please do, and leave the information right down here in the comment section below. Right down there. Okay? A plane angle is a plane angle is the inclination to one another of two lines in a plane. Okay, obviously these two lines are not floating out in space, they're right here. Okay? Which meet one another and do not lie in a straight line. Well, these two lines meet one another, and this line right here is not an extension of this line right here. There you go. And when the lines containing the angle are straight, the angle is called rectilineal. Okay? Let's refer back to the square. These are straight lines. Both of them. You have a 90-degree angle here. Okay? This is a rectilineal angle. When a straight line is set upon a straight line, okay, let me try this again. When a straight line set up on a straight line makes the adjacent angles equal to one another, each of the equal angles is right. Okay? Let's go ahead and extend this line out. And there's a reason for that. Alright, we're going to extend this line out too. Okay? Okay. We've extended these two lines out. I hope you can see them. Maybe you can't. Ah, there we go. Now you know I already drew the square and I just extended the two lines out here and here. Okay? Now, what are adjacent angles? Well, this angle and this angle. These two angles are adjacent. They're right next to each other. This angle and this angle are next to each other. And this angle are right next to each other. So what did Euclid say? He said, when a straight line set up on a straight line, well, this is a straight line, this is a straight line. They're set upon each other. If it makes the adjacent angles equal to one another, well, this angle is exactly the same size as that one, and this angle is exactly the same size as this one, and this angle is exactly the same size as this one. Each of the equal angles is right. We already proved that. And the straight line standing on the other is called a perpendicular to the one which it stands. This line here is perpendicular to this line. That's what he's saying. Now, what's an obtuse angle? Well, let's refer you back to that picture right up there. That's obtuse. An obtuse angle has more than 90 degrees. Now keep in mind that when Euclid was doing this, it was, when Euclid did this, he didn't have measurements. He didn't measure his angles. I know you're used to the protractor. Do not use the protractor when doing this. Okay? Because he didn't use it, and neither shall you. What's an acute angle? Well, let me show you what an acute angle is. I'm going to draw this line right here. Maybe. Then you're going to draw this angle right here. Beautiful. Okay. An acute angle has less than 90 degrees in it. But remember, Euclid didn't have measuring instruments for those kind of angles. Get used to that. A boundary is that which is the extremity of anything. Okay? The boundary of a line is a point. The boundary of a surface like this is a line. There you go. A figure is that which is contained by any boundary or boundaries. Well, these four lines contain that surface. That's what he's saying. Perfect. Let's go on. Let's talk about circles, shall we? I'll flip this baby upside down. Let's draw us a circle. What you're going to do with the compass, make sure you can see this. Okay. Put the compass, let's put it up here. Hey, that's good. Let's not do that. You got to make sure when you're using these things that your point, well, it's still trying to do cattywampus things. Make sure it's nice and tight. Because if your needle moves, so does your instrument. Ah, damn. This won't be the most perfect circle in the world. Only because we are not doing this right. I hate to tell you this, but it's been a very long time since I used a compass. Of course, it really isn't. I have to admit, this is getting downright irritating. trying to make sure this tool does not move. Well, basically, that's a circle, okay? And you've kind of seen how to draw the circle. Let's go through this. A circle is a plane figure. This circle is not outside of a surface, okay? The circle is a plane figure contained, okay? A circle is a plane figure contained by one line such that all the straight lines falling upon it from one point among those lying within the figure are equal to one another. Okay, what does that mean? We're going to say, as when we were drawing this, okay, so we're going to say that alright, I was slightly interrupted for a second, but let's go ahead and finish this up. Okay. Now what Euclid was trying to tell you is that this line here and this line here are exactly the same size. And if you draw a line from this point to any part of this circumference around here, because I know what I'm going to hear, well, why didn't you tell us what this was? Okay, well, first of all, this is a circle, this is a radius, this is a radius. The plural of the word radius is radii, R-A-D-I-I, okay? And if you know anything about radium or radiation, they come from the same dang word. As a matter of fact, even the sun ray, you ever seen rays from the sun? Same thing, okay? Now, this out over here is the circumference of the circle, okay? And this is where you get the 3.14 and the pi and the whole 9 yards. You get all that, alright? So, let's go on. But anyway, what Euclid's saying here is that a circle is a plane figure. It's not outside this surface, okay? Contained by one line. The circumference is the one line, such that all the straight lines falling upon it from one point, okay, this is the one point, and all the lines falling upon it, which means that it goes from here to here, here to here, so on and so forth. These are all the radii, okay? That's what he's talking about with those lines, okay? When he says straight lines, he's referring to radii. All the straight lines falling upon it from one point among those lying within the figure are equal to one another. He's just saying that every line that you draw from the center of the circle to the circumference, those radii will be equal. Duh. And the point that he was talking about in the last definition, he calls the center of the circle. Well, that's the center. Okay, now he refers to a diameter. Let's draw the diameter of this circle. Can you see me? Good. Okay, let's draw the diameter. Alright, this line right here is a diameter. But let me read what he exactly said. He said, a diameter of the circle in any straight line drawn through the center and terminated in both directions by the circumference of the circle, and such a straight line also bisects the circle. Okay. Now, that's a lot of stuff there. A diameter of a circle is any straight line, well, this obviously is a straight line, drawn through the center and terminated in both directions by the circumference. Okay, this line went through the center of the circle. It was terminated by both sides of the circumference. Okay, and such that a straight line also bisects the circle. Okay, so there's as much area on this side of the circle as there is on this side. I know it don't look that way, but there is. Okay. Now, what is a semicircle? Well, Euclid says a semicircle is a figure contained by the diameter. So this semicircle is contained by this diameter, and the circumference cut off by it. Okay, so everything inside, okay, now here's the circumference here, here's the diameter, and everything between this diameter and this circumference is a semicircle. Got it? Good. And the center of any semicircle is the same as the circle itself, because you have to draw a circle to make a semicircle, unless you've got a computer and you can fudge the whole thing. Alright, rectilineal figures are those which are contained by straight lines. That's a rectilineal figure, that's a square. It's contained by straight lines, 4 straight lines to be precise. That's a rectilineal figure. Okay, what is a trilateral figure? Well, let's draw one, shall we? That is a trilateral figure. Okay? What does Euclid say? A trilateral figure is a figure that is contained by 3 lines. Yeah? 1, 2, 3 lines. What is a quadrilateral figure? Well, it's a figure that is contained by 4 lines. 1, 2, 3, 4. What is a multilateral figure? Well, a multilateral figure is a figure that is contained by more than 4 straight lines. Look at a star. Anytime anybody has drawn a star, it is contained by more than 4 straight lines. Boom. Of the trilateral figures, okay, this is a trilateral figure. We have an equilateral triangle, and if this was an equilateral triangle, all 3 of these sides would be the same length. Okay? If you have an isosceles triangle, and I'm going to try my best to draw an isosceles triangle here. Okay? What you basically have is and this is not going to be exact, I can tell you that. Oh, for heaven's sakes. Alright. That's about the best I could do without measuring everything out and making it perfect for you. But anyway, that would be more like your isosceles triangle, okay? Now, an isosceles triangle is that which has 2 of its sides alone equal. So these 2 sides would be equal in length, and this side would not. Okay? And a scalene triangle would have 3 sides not equal in size. Okay? So let's take this one right here. Because if your triangle has an obtuse angle, there's a very good chance that none of these sides are going to be equal in length. Okay. Further, of the trilateral figures, a right angle triangle which will have one right angle. Okay. Let's make a right angle triangle. We're going to go back over here now, because we're cluttering up that page. Let's make this right angle triangle. This is your right angle triangle. Okay? Let's go through this again. A right angle triangle is that which has one right angle. An obtuse angle triangle is one that has an obtuse angle, and that would be this one right here. And an acute angle triangle is that which has three acute angles. Okay. This basically would be your acute angle triangle. Of all the quadrilateral figures, a square is a figure which is both equilateral and right angled. Well, okay. That means all four of these sides here are equal in length, as well as it has four right angles. 1, 2, 3, and 4. There you go. What is an oblong? It is any figure that has right angles, but it is not equilateral. Okay? Now, you can look some of these up for yourself. I'm going to let you do that. A rhombus is that which is equilateral but not right angled. A rhomboid is that which has its opposite sides and angles equal to one another but is neither equilateral nor right angled. And let quadrilaterals other than these, other ones I just mentioned, be called trapezia. Now I will display all this on the screen, so you can look up these words and see it for yourself. Final definition. Okay, this is the 23rd definition. Parallel. What's the definition of parallel according to Euclid? Okay. Well, first of all, we're going to draw some parallel lines. Get ready, because here they come. These two lines are parallel. However, Euclid says parallel straight lines are straight lines which, being in the same plane, because they're not floating around in space, and being produced indefinitely. Okay, now these lines are not indefinite, but if they were to be produced indefinitely, in other words, they were to stretch all the way across the face of the earth, if they're produced indefinitely in both directions, so this would go this way, this would go that way, but they would go on forever. Okay? These two lines will never meet one another in either direction. And that's the definitions. Alright, in my next video, I will show you the postulates. Euclid's postulates. Alright, I will tell you more in a future video, so I'd like for you to stay tuned.